Hello everyone, welcome to Mhlongo's Mathematics and Physical Science YouTube channel, and I'm responding with this video to a request that was made on the paper from the Northern Cape. I think it's March 2023. Someone said, can I do the whole paper? So I'm doing question 4, which is um, momentum and impulse, because we've already done question 2 and 3. And so we'll start by reading what's on the statement. So a man on roller skates having a combined mass of 87 moving horizontally at a constant speed in a straight line sees a boy with a mass of 22 standing directly in his path. The man grabs the boy and they both continue in a straight line at 2.4 meters per second. Right, question 1 wants us to, 4.1 wants us to state the law of conservation of momentum. And if you still do not have the exam guideline, please comment and we'll see how we can, or just send us an email, maimhlaba@gmail.com. Then we'll definitely share the exam guideline with you. Right, 4.1. All right. Before I start with 4.1, sorry, I discovered something when doing this question that physics is about imagination and seeing what you are doing. So before we can start with 4.1, let's draw a scheme of what is exactly happening here. So we have a case whereby this is before the collision and there was after the collision, right? Now, before, they're telling us that I'm gonna show my artistic skills. There's a man on some roller skates. Okay, I think, and this man with the roller skate has a combined mass of 87 kilograms, and he has a constant velocity. So I'll call it V man. Has a constant velocity that we don't know. And in his pathway, there is a boy that is just standing with a mass of 22 kilograms. So the boy is standing, there is no velocity there, so V of boy will be 0. Now, after the collision, the man grabs the boy. So they are now together. Mr. Roller Skates. I know the roller skates are not the core subject of what is happening. Okay, now after the collision, let's go back to the question. After the collision, they are both traveling at 2.4 meters per second. So, which means V final is 2.4 meters per second. So that you'll be able to visualize what exactly was happening in the scenario. So now we can go back to 4.1 that wants us to state the law of conservation of momentum, which is 4.1. And the law of conservation of momentum states that the total linear momentum of an isolated system remains constant, or you can say E is conserved. Right. And in 4.2, say we have to calculate the man's speed just before he grabs the ball. So with now having this scheme of before and after, because most of the momentum and impulse questions always have a before and after well scheme drawn for you. So in this one, they did not. So it means you need to visualize, get used to something that you used to. You need to visualize. So in 4.2, now we're applying the total well, the law of conservation of momentum that says sum of momentum before or sum of momentum initially uh, is equals to the sum of momentum finally. So we'll start by m1 v1 initial, which is the velocity of the man, plus m2 v2 initial, which is the boy. Now, after the collision, they are now one. The men grab the boys, so which means their masses are gonna be combined. So mass 1 plus mass 2, and they'll be traveling at the same velocity. So it's a V final. Okay, now our values are up there, whereby the man has a mass of 87 times his V1 initial plus the 22 kilogram boy who is standing, and this will be 22 plus 87 or 87 plus 22 multiply, and they both travel at what, at 2.4. Now if we get this, we get 87 v1 initial plus 0 will be equal to a 261.6, and we divide both sides by 87, and we get v1 initial is equals to 3,01 meters per second. Right. Now, question 4.3 asks that is the collision elastic? Then use a calculation to support your answer, and that's for 6 marks. Right. How do you tell if something is elastic or inelastic? Well, by visualizing, you can tell, and also by calculation. So by calculation, we have to calculate how much energy was dissipated before and how much energy was um, used after. So you have to try and calculate that EK before alone. So you don't do EK before is equals to EK after, because if you get an um, if you get a sum on the left hand side that is not equal to the sum on the right hand side, then your equal sign uh, is wrong actually, because the two equations will not be equal, and you've stated from the top that they are equal. Mathematically, that will be incorrect. Okay, so before we had half mass 1 v1 initial squared plus half mass 2 v2 initial squared. So it's a half of uh, 87 times 3,01 squared plus half of 22 0 squared, which is equals to get a sum of 394,11 joules. Then kinetic energy after is equals to the half of mass 1 plus mass 2 V final squared, which is going to be equal to a half of 87 plus 22 times 2.4 squared. Then we get 313.92 joules. Then we can see that EK before is not equal to EK after. Then we make the conclusion that the collision is inelastic. Or you can say that no, because the question was asking us, is the collision elastic? So you can make two conclusions. So if it was elastic, the kinetic energy before was going to be equal to the kinetic energy after. Okay, so thank you for watching. Please like, share, and subscribe. And thank you.